Okay, so yeah, let's talk about some applications of systems. These problems on the handout, we can turn those into a system, and that'll allow us to figure out the answers here. So on number one, we're looking at ticket problem. We've got 5 regular price tickets, 6 student tickets, $112, 4 regular, 4 student, $83. And so doesn't that seem to suggest a system pretty clearly, I think, because, yeah, we've got two types of tickets. So if X is our regular price and Y is the student price, then the top equation is a nice little equation. It would be, well, we've got 5 X's and 6 Y's, right? And that equals 112. And then we've got, on the second one, we've got 4X plus 4Y equals 83. With me on that? Make sense? Yeah, just multiply the number of tickets by the price in each case, add them together, and you got the total price. Yeah, so that's a nice system solved by, which way would you suggest? That'd be elimination, wouldn't it? We can eliminate the variables. I'm seeing, you can see the X's, I can do the Y's either way, but I'm going to do the Y's here because their LCM would be 12, wouldn't it? Both of those are multiples, have multiples of 12. So I'm going to make one be 12, the other negative 12, so that would mean multiply the top by 2. That would give me 12y, so it would be 10x plus 12y equals 224. And then what about the bottom? Bottom I need to be 12, but it needs to be negative 12, so multiply by, how about a negative 3? So it would be negative 12x minus 12y equals negative 3 times 83. Is that negative 249? Does that sound right? Is that okay? All right, and so then what do we got? 10x minus 12x is negative 2x. The y's eliminate. 224 minus 249 is negative 25, I believe. Then divide off the negative 2. And so x is, that would be 12 and a half, wouldn't it? And so then the y, so need the y. So plug in the x to be 12.5. And we got it. Let's see, 5 times 12.5. 24.5? No. 24.5. What is 12.5 times 5? 62.5. Okay, thank you. Yeah. All right, and then plus 6y equals 112. Subtract off our 62.5. And I'm seeing 6y equals 112 minus 62.5. 49.5. Divide by 6. And we've got y equals 825. So that tells me what? That tells me x is this regular price. So I've got $12.50 is the regular price. And $8.25 is the y, so that would be the student price, right? Does that sound okay? All right. Any question or concern on number 1? Number 2. We got that one. We have a number 2. Well, we have a total, excuse me, a total of $60,000 is invested in 2 accounts. One account pays 8% interest, and the other 6.5%. Simple interest here. If a total interest is $4,500, from these desired investments, how much should be invested at each rate? All right. Yes, since we are on the idea here of systems, let's see if we can get a system out of this. If we have two accounts, we've got two amounts. Let's call the amounts X and Y. And so if there's $60,000 invested in those two accounts, doesn't it seem to reason X plus Y would have to equal $60,000? I think so. X plus Y would equal $60,000. The other equation comes out of the interest here. Now we're talking simple interest, and simple interest is principal times rate times time. You know, we looked at the compound interest before, but this is just simple interest, which is principal times rate times time, and even better yet here, we know our time is 1, so it's just principal times the rate is interest. So I'm just going to take the principal of each one times the rate, and that gives me the interest. Well, the principal of the 8%, that's my, let's just call that the first account, so the principal is X, so just multiply those two together, that's 0.08X. The principal for the 6.5, let's call it the Y one, so that would be 0.065Y. And what I know about those two is that they're total to be 4,500. So add those two up, and you have you do have 4,500 there. Okay. Now this one could go either way. We could eliminate. We could like multiply. We could multiply like this one by negative 0.08, but this one also is a good one for substitution. If I just move move the X over here and make it Y equals 60,000 minus X, I can be about the same. Then I can plug in for Y the 60,000 minus X. So it'd be 0.08X plus 0.065 times 60,000 minus X equals 4,500. 6 of one, half dozen the other, right? Works either way. All right, so then 0.08X plus, just distribute your 0.065. I get 3,900. I'm going to multiply that, and then I'm going to multiply that. I get minus 0.065X. That equals 4,500. I've got X terms, so combine those. That would be, what, 0.015X. 0.08 minus 0.065. Subtract the 3,900. And so 0.015X would equal 600. And then divide off the 0.015, and we got our X. Divide. I multiply first time. 40,000. Well, that's the X amount, so the Y amount, we know the two add up to be 60, so that would put Y at 20, wouldn't it? 40,000 and 20,000. 40,000 is the 8%. The 20,000 is the 6.5%. Is that okay? Does that look okay? All right on that? Any question or concern? All right, number 3. On the back side of the handout there. Cost of producing X units. So X units cost C equals 500X plus 10,750. And the revenue for selling X units is R equals 950X. So we produce X units, we get cost of 500X plus 10,750, revenue, multiply 950 by X for selling that number of units. Find the sales necessary to break even. Well, what we're wanting there, of course, is when we break even, the cost and the revenue, what would be true about that? They would be equal, yeah. Our cost would exactly equal our revenue. And so this, we do have two equations there. So this is technically call it a system here. But what we're looking for break even is we're looking for where the cost equals the revenue. And so that is pretty much sums up this problem, doesn't it? Because what I want to do is set the cost equal to my revenue. So we just set 500X plus 10,750 equals 950X. So again, just a pretty simple little solving here. Subtract the 500X, and looks like we would have 10,750 equals 450X. Divide off the 450. And so we'd have to produce and sell, how many is that? 23.88 equals X. So it looks like 23 wouldn't be quite enough. It needs to be 24, doesn't it? These were just, yeah. Sometimes it has it in hundreds and things, but this is just straight up. So I would need 24 units there. Okay? All right. Now, number 4 is a similar one. It's a little extra step. Company invests $70,000 to produce a new product. So we have an initial investment of $70,000. If each unit of the new product costs $85 to make, and each unit sells for $120, how many units must be sold to break even? So again, I want the cost equals the revenue. All right, but let's, in this case, though, the thing is we're not given the cost equation, nor are we given the revenue equation. We have to fill that in for ourselves here. But that's not too bad. What would the cost here be to produce if X is the number of units? What would be the cost to produce X units? Well, we have 70,000 up front, so it'd be 70,000 plus each unit is 85. So if I want the cost, then I'd have to take 85X, wouldn't I? How many ever units I produce, I've got $85 for each one. So 85X plus the initial 70,000. The revenue then, well, I sell them for 120. So the revenue I get is 120 times the units, right? 120X. So I want to break even, set them equal, right? 70,000 plus 85X equals 120X. Subtract the 85X. 70,000 equals 35X. Hey, how about that? Divide by 35? 2,000. Right on the dot, right? So I need 2,000 units on this one.